You are welcome to the problem of the day. Problem of the day. Two identical spheres have equal and opposite charge, which is the charge equals 100 nanocoulombs and hang on strings of equal length. L equals 50.0 centimeters, making equal angles. Theta equals 10 degrees with the vertical reference line. The sphere are in a uniform electric field of 100,000 Newton per coulomb as shown. Determine the mass of one of the spheres. Okay, so this is the diagram to support the question. Now, what we can do is that we can close this up. So if we close this up, we can see that there is a force according to the Coulomb's law that attracts both charges because they are equal and opposite in charge. So if the distance between the two charges is r, then it means that here is r over 2 and this side is also r over 2. Now this is L, and up from the question, L is 50.0 centimeters. Now we know that since it is a string, then there will be a tensional force in this string. And then since it is a charge, the charge has a weight that acts perpendicularly downwards, and the weight is given as the mass times the gravity. But we can see that the attractive force for the positive charge is moving in this direction, and for the negative charge too is moving in this direction, and therefore there is a Coulomb force at this point. So let's single out this triangle and make some inferences from it. So drawing that part of the triangle out, then we can see that here is theta, and we're giving theta as 10 degrees. And then in terms of the forces, and this is this charge, the minus Q. Now, the tensional force is here, and then the weight, mg, is this part because it acts downwards. So here is mg. And then the Coulomb's force, Fc, it's here. But the question didn't say anything about the tensional force. It rather spoke about the weight and then the Coulomb's force. So what we need to do is to determine the relationship between the weight and then the Coulomb's force. So if we use tan, you see that tan theta is equal to the opposite, which is Fc, the Coulomb's force, divided by the adjacent, which is the weight, mg. Now, what is Fc? Fc is the force between the two charges, and therefore, let's write from Coulomb's law, we know that the force that acts between two charges is the product of their charges. So the Q plus then times the Q minus. However, there is this constant K divided by the square of the distances between them, which is r squared in this case. But the question says that they are identical. Since they are identical, then Fc is equal to kq squared divided by r squared. So if we bring it here, it implies that tan theta is equal to kq squared divided by r squared mg. So this is tan theta. Now, having found tan theta, from the question, we're given the charge, we're given the gravity, which is 9.81. But we don't know the radius, and we are looking for the mass. So let's make the mass m the subject. So m is equal to kq squared divided by, then here becomes r squared g tan theta. So here's tan theta. Let's single out this triangle again and try to determine the relationship between the length of the string and then r and then theta. So in singling out that portion of the triangle again, then we see that here is theta, which is 10 degrees. And then, so let me use theta instead. So here is theta. And then here is L, the length. And then we were not given any information about the side of the length, which is this side. but we know that here is r over 2. Now if we use sine is opposite over hypotenuse. You can see that sine theta is equal to the opposite, which is r over 2, all divided by the hypotenuse, which is L in this case. So sine theta is equal to r over 2L, and therefore r is equal to 2L sine theta. Now if we are looking for r squared, then it means that r squared is equal to all of this squared, so like we are squaring both sides. So 2 squared is 4, and L squared, then sine squared theta. So that is r squared. Having found this, let's go ahead and then put it in the formula to find m. So from here we can see that m is equal to q squared divided by r squared, and r squared is 4L squared sine squared theta, then times j, which is this, tan theta. So let me rewrite this well. So we can see that, so this is m equals, so m is equal to q squared divided by 4L squared j tan theta sine squared theta. So we just rewrote this equation again. So we got the mass as kq squared equals 4L squared j tan theta sine squared theta. So let's go ahead and insert the values and find the value of the mass. So k is a constant, which is 9 times 10 exponent 9. Then times q is the charge, and that is 100 nanocoulombs. So 100 times 10 exponent negative 9, then squared, divided by 4 times, the length was 50 centimeters, which is the same as 0.5 meters, squared, then times j is 9.81, as gravity, then tan theta, which is tan 10, times sine squared theta, which is sine squared 10. All of this squared is the same as 10,000 times 10 exponent negative 18. All of that divided by 4 times 0.5 squared is 0.25 times 9.81, and times tan theta is 0.176, then sine squared theta is 0.174 squared. So the value of m is equal to 0.0017 kilograms, which is the same as m equals 1.7 times 10 exponent negative 3 kilograms.